All right, good morning, everyone. Hope you all had a great weekend. I'm saying weekend, of course, because we didn't meet Tuesday. So hope everyone did a great job on the exam. I was pretty pleased with the grades overall. I applied a 7-point curve to the raw scores. So you should go ahead and see that reflected inside the raw scores. Beyond that, I went ahead and recalculated your grades just to give you an idea of where you are. Most people are doing pretty well. For those of you who aren't, well, I don't really know what to say there. It's probably a case-by-case basis, but certainly continue to study and learn the material. Pretty straightforward in terms of all that. So the grades should be posted. If there's any questions, feel free to talk to me after class. I can pull up the exam questions if you have any questions about any of the exam questions there. But apart from that, no one threw any spitballs at me this morning, so I guess no one's too mad at me. Do want to go over the schedule briefly. Last unit, so we're wrapping up the semester. This unit will be covering data analytics. That's this class and next class. This class will be focusing on the sort of theoretical lecture component. Next class we'll do some basic examples of data analytics. The 18th and the 23rd, we're not going to meet in person those 2 days. Just wanted to go ahead and let you all know that. I will do one lecture and just have it on my YouTube channel. We will meet in person on the 25th, so that's March 25th. Then you'll notice there's a couple days where there's nothing on the schedule. Wanted to give you all a spring break, so we're not going to do anything from the 25th all the way up until the 8th of April. So the 8th of April, we will have the lecture for wireless mobile computing and commerce. And then the final lecture is going to, well, it's not the final lecture, second to final lecture, rather. It's going to be the 13th of April. That's going to be Chapter 6, Telecommunications and Networking. In the final lecture, we will do the Technology Guide 3, which I think is Cloud Computing, and the course review. So you can ask any questions you want. You can either ask them, of course, in class if you want to do that. I'll also send out a survey like last time. The final is going to be mandatory. It's going to be cumulative, and it can replace one of your 2 exam grades if it benefits you. So like I said, there's going to be 3 options. It can either count 20%, it can count in place of exam 1, or it can count in place of exam 2. So that's kind of how that will work. Whichever of those options is highest is the one that will count. So any questions about anything? All right, like I said, feel free to see me after class if you have any questions you didn't want to ask right now. That's totally okay. So today, we're covering Chapter 12 for Business Analytics. So this chapter is a really interesting chapter. It really kind of breaks down a lot of decision making. So we're going to start off by talking about the managerial process a little bit, what a manager actually does in the day-to-day sort of atmosphere. Then once we do that, we'll kind of break down and talk about analytics. We'll talk about 3 types of analytics, descriptive, predictive, and prescriptive. So each of those will kind of give some examples, say why they're used. Then we'll also talk about presenting information, presenting knowledge, some different tips and ways to do that. So I'm going to start off with a quick little video here, just kind of get everything going. So make sure I've got myself muted. Okay, so I've just got that in there to kind of introduce data analytics. And you'll notice that they said 2 databases. All the data inside of each database is wrong. So what does that mean? What kind of insight can we get from inaccurate data? Now, I should quantify that statement a little bit and say, let's assume that it's not wrong in a systematic approach. If it's wrong in a systematic approach, it'd be some sort of transformation that took place to the data. Maybe we added 200 to each value incorrectly. And in that case, all we'd have to do to correct that is to just subtract the 200. We've got accurate data. Or let's say it was applied some sort of multiplier. Maybe we multiplied everything times 0.5. Don't know why we would. Let's just say we did. All we have to do is just multiply everything by 2 to reverse that. So pretty straightforward if that's going to be a systematic error inside the data. Let's say it's idiosyncratic. We don't know what is incorrect inside the data. It could be wrong on some observations by a factor of 2 million. Others, it could be wrong by a factor of negative 2 million. We don't know. So if that's the case, can we gain any insight from that data? We could, but the insight wouldn't necessarily be accurate. So we definitely want to make sure that our data is accurate. Think back to the CIA triad. We have confidentiality, availability, and integrity. We want to make sure that our data has integrity so that we can actually gain meaningful insight from it. So that's what we'll be talking about today. We could certainly do anything we wanted to with faulty data, but it's not going to be meaningful. So what we're talking about is business analytics. And business analytics are going to be some sort of an overall process that's going to help us gain actionable insights to make better decisions. And you'll often hear of business intelligence. So business intelligence is going to be a broader topic. It's going to include not only the processes, it's also going to include the applications that are involved with the processes, as well as the technologies. So it's kind of like information systems versus information technology. Information technology is a subset of information systems. In this case, business analytics is going to be a subset of business intelligence. But in practice, people don't really make that distinction. So if there's going to be an exam question asking you the distinction, that's what it is. But I don't think I would do that. I might have. I don't remember exactly. I'll have to check on that. But certainly make sure that you know both of those. When you go out in the private industry, though, you don't have to worry about the difference. So we kind of talked about a little bit about managerial decision making. So first, let's say what a manager is. It's a person who's responsible for something at a company. It's going to contrast with typical run-of-the-mill employee, and that typically we think of a manager, someone who manages employees. And there's a lot of different ways they could go about that. It could be that they're not actually managing employees. It could be they're managing resources. But most of the time when we're talking about managers, we're talking about someone who is making decisions relating to employment. So they may have decisions that they may have to allocate resources, make a budget. They may have to decide what gets purchased, what doesn't get purchased. They may have to decide who to hire. They may have to decide the opposite of who to hire, who to let go. These are all decisions that are commonly made by managers. And of course, we think about that, we kind of see how can we best make the decisions that are going to benefit the company the most of the time. And of course, there's lots of different ways we could do that. We're going to talk today about using an analytical approach to help justify decisions to make sure that we're not making incorrect decisions. What could happen if we make an incorrect decision? Anything. We could lose money. We could become completely solvent. None of those would be very good. So we want to avoid that, and that's what today's lesson is going to cover. Now, one of the most important things to kind of understand, though, is that managers are very concerned with productivity. And productivity, in a business sense, is a very important thing because it's saying how efficient your operations are. So what you're doing, productivity, taking your inputs, dividing them by your outputs. Now, in this case, we want our inputs to be lower than our outputs. Now, I'm going to make a little bad joke I make every year. This is one of the few times we can actually violate the conservation of matter. In other words, we're creating more than we're putting in. Now, I know from other standpoint, we're not actually doing that. But that's what we're doing from a mathematical standpoint. We want to input fewer dollars than we output. If we're losing money, what does that mean for the firm? It means we have a limited amount of time we can sustain our operations. So we want to make sure that we have a productivity that exceeds 100%. If we don't have a productivity above 100%, it means that we're going to become bankrupt. And that's never a good thing. So let's talk a little bit more about the specific roles that a manager has. So first here, we have the interpersonal role. And this is going to be the role where they're really working individually with people. They're interacting with lots of people. This is where they're really kind of serving in that role, and a lot of times this is seen as like a mentorship relationship. I could also think of this as a figurehead, the face of the company, so to speak. Interacting with people in that way, certainly going to be something we have here. Being a leader, serving as a liaison. Could be there's a sort of thing where there's two different departments, they have to interact with each other. That will be the interpersonal role, having that liaison to be able to facilitate the communications between two or more departments. We have the informational role, sharing information. So this is where we do things like monitor. We see what people are doing. Certainly an important thing. If we have no idea what our employees are doing, we could have a lot of problems. Disseminating information, serving as a spokesperson for an organization. Communicating new products with clients, communicating new products with employees. All these are sort of things that we would do there. Then lastly, we have the decisional role. So as the name would imply here, making decisions. And that's really what we're going to focus on primarily for today, making good decisions. So this is things like handling disturbances, serving as a negotiator, a mediator, whatever the need may be, to really kind of make sure that not only are we making decisions, we're making decisions that people are happy with, at least as little unhappiness as possible. You can certainly imagine very few decisions that you can make where someone won't be upset by something. If I made a decision to award bonus points, someone may be upset that I did that, because maybe they think that grades shouldn't have bonus points. Now, I don't think most people would think that way, but no matter what decision you make, people are going to be upset. So it's important to recognize that, and that's one of the roles of a manager, is to kind of deal with that sort of emotional aspect. Let's take a quick look at this decision support framework. This is a famous piece. This is basically where we get the idea of types of decisions. So you see here we have unstructured decisions. That's going to be decisions where there's a tremendous amount of uncertainty. We don't know what the outcomes will be based on the information we have. We may not even have any information about the decision. It's going to contrast pretty heavily with structured decisions. In a structured decision, we pretty much know exactly what will happen based on the information that we have. So imagine we're a bank. We have a really good idea whether people will repay a loan based on information about the people. Not to say we have 100% certainty, but above 99% accuracy, we have a pretty good indication whether someone will be able to repay a loan. And certainly when we look at that over millions of customers, we're not going to lose money if we're loaning money. Now you could make an argument, what about exogenous events in the economy? Let's say there's a big recession. Well, could that change the model? Yeah, of course. But for the most part, we're talking about in the present time, we know whether people will repay a loan or whether they will not, with a very high amount of certainty. That's going to be a structured problem. Unstructured problem, typically going to be something where we don't know what will happen. So imagine we wanted to, say, buy a new factory in a new country. Let's just say Brazil. We want to start a factory up in Brazil. Do we know anything about Brazil? Well, we know they have a river. We know some other stuff about them as well. But we don't know how it's going to work with a factory. There's a lot of uncertainty there, even though we can look up basic information about the country of Brazil. And then semi-structured, going to be a tougher one to kind of define. It's going to have some known circumstances and some unknown circumstances. So let's just look at the examples we have here. Things like credit evaluation. You can certainly tell whether someone will repay a loan, but to actually evaluate the credit on a more quantitative basis, a lot more difficult to do. Things like HR policies. There's a lot of uncertainty when it comes to what will happen in the next 5 to 10 years for a company. So that's sort of what we're talking about there. If I were to ask a question, I would ask either structured or unstructured. I think semi-structured can be a little bit confusing between the two. Does that make sense? Okay, let's talk about business analytics. We've kind of talked about decisions, talked about why companies need to make decisions, what sort of decisions companies make. Let's talk about analytics. So first thing to say about analytics is that it's going to vary widely by organization, even more widely than something like the ethical handbook between a company. I mean, it's something that really companies have individual needs. Not only do they have individual needs, they have individual desires. So one company may want to have one piece of information that another company may not care about. So this is something where one process, one company, completely different from another. So really what we're doing is we're making sure that we're developing things that are scalable, that they can adapt to changes, changes in management, changes in company structure, changes in sales, changes in location. Whatever we're developing, we want to make sure not only we're doing that, but this is supported enterprise-wide. Because if it's not supported enterprise-wide, it means that whatever we're doing is not being used. And if we're not having our system be used for making decisions by the company as a whole, what good is it? You know, it'd be like if I wrote a research paper and no one ever read it. Did I waste my time? Yeah. So that'd be a bad thing. So you certainly want to make sure that it's enterprise-wide. And how do you get to that point of having the analytics be enterprise-wide? One key factor, it's going to be upper management support. If your upper management doesn't support something, you either have to convince them to support it or you give it up, because otherwise it's going to be an uphill battle, and there's really no reason to do that. So that'd certainly be what I would advise. But the whole goal here is to really have this in place to where you can support organizational change. And not just organizational change, but organizational transformation. So, you think back to the old way of doing things. The old way of doing things based on gut feelings a lot of times. Could be based on perceptions. Could be based on anything. But now we have the ability to make changes based on real data. I think that's pretty exciting. So this is certainly something that we can do using analytics. So let's talk about how we actually get to enterprise-wide. So this is from Davenport, and it identifies 5 key stages of analytics. So the first stage is going to be analytically impaired. And what that means is that the company is not using any analytics at all. So they're not collecting the data, they're certainly not disseminating the data, they're not analyzing it, nothing. So that's basically saying they're not using it. Then we have the localized analytics. And inside a localized analytics phase, what we're saying is we have one or more functional units. Typically, we're thinking of one functional unit that is beginning to collect and beginning to perform data analytics. So this could be a sales team wanting to better understand their customers. It could be a finance team wanting to better understand the company's financial situation. It could be a production team wanting to better understand the production. Whatever the case is, it's going to be typically one functional unit. Could be more than one, but not the entire company. So certainly, we think back to talking about information silos. This is an information silo for one functional unit. Then, beyond that, we have analytical aspirations. This is where we're starting to get the upper management buy-in. We have our executives. They're really excited about analytics. They're excited for the possibilities that it could bring a firm, and they're wanting to then apply it to the company as a whole to enhance the decision-making of the firm. So we're not to the point where it's actually being used in the company, but this is a phase where we'd be beginning to build it out. We'd be beginning to acquire the contracts needed, beginning to maybe recruit personnel to support it. Whatever the case is, this is where we're beginning to lay the groundwork for that next phase. The next phase, of course, is going to be analytical companies. So in analytical companies, it's company-wide. We have upper management buy-in. Really, the only contrast between analytical companies and analytical competitors is that once we become an analytical competitor, it's guiding our strategic decisions. So if we're wanting to decide, should we build a new factory in this location? We'd use analytics to support that decision. And we'd say, based upon the market data that we have, based upon the consumer data, whatever data we want to base it on, we believe this would be an advisable decision. So we're really using it to make strategic decisions and really to make competitive decisions as well. So not only would we collect data about our own company, we could also collect it about rival firms. So a lot of that data is going to be publicly available. If it's publicly available, we might as well collect it. It certainly would be advantageous to do so. Then we can kind of see what our rival firms are doing. We can react to that. We could even react to it before they have a chance to react. So it can certainly be beneficial from that aspect. Those 5 stages clear to everyone? All right. So let's talk about how we actually use business analytics. So we kind of talked about the advantages, talked about how they're used, But how do we actually get them? Well, we follow a process pretty similar to this one. Again, this can vary by company, so don't take this too literally. But the first thing we want to do with anything major like this is consider strategy. So look at the strategy of our firm. If it's cost leadership, if it's going to be differentiation, whatever our strategy is, we consider that first, because that's really going to drive the ways that we would use analytics. Let's say we're a cost leadership firm. Would we want to use our analytics to use insight about customers who only want to buy a completely novel product, or would we be more interested in customers who may be price sensitive? For cost leadership, we'd probably be more interested in the customers who are going to be price sensitive. So we definitely want to keep that in mind. That's going to be central to whatever we're doing here. Then, of course, once we kind of considered what we're, the overall sort of goal of this, we need to kind of get in and make sure we have the data to support that. So this is where we talk about the managing data. I think that was chapter 5. Yeah, chapter 5. So think back to chapter 5. Talked about databases, talked about knowledge management. This is where we'd actually kind of determine what data we need to collect. Do we need to collect information about our sales, information about our customers, information about our employees, transactions, any sort of data like that? It's going to be very beneficial to us. And once we've kind of determined how we manage it, it's going to be a very top, sort of approach where we kind of determine how we're going to store it, where it'll be stored, how it will be accessed, where it'll be updated from, because a lot of this information is going to be non-volatile. So that means that we can't edit it from the analytic application itself. Now, why could we not edit it from the analytical application? That's actually a very beneficial thing for us, because that's going to prevent a lot of fraud. Certainly, if each and every employee has access to something, you want each and every employee to be able to edit the data. So they can't. That's what we do inside the managing data phase. Then once we've got the data collected, we actually got to analyze it, determine what we actually want to do. So 3 types of analytics that we're going to discuss: descriptive, predictive, and prescriptive. And we're going to cover those in a couple slides, so don't get too caught up for now. But that's what we're doing inside the analyzing phase. We're actually looking at the data, determining what sort of insight can we gain from it. How can we better compete with this data? And then lastly, we don't just stick to analyzing it, we do something about it. This is the act phase. This is where we actually would go through and we would form strategic decisions and then engage in them. Of course, I guess the last phase would be to reflect on that. How did it go? Could we have done things better? Did things go really well? That's basically what we're doing inside this process. So kind of shifting gears a little bit, we'll come back to the types of analysts next couple slides. Kind of shifting gears a little bit, talking about how we actually present data. This is an important thing to consider, because imagine if you were presenting data and no one understood what you're talking about. Would that be an effective presentation? Would it be a complete waste of time? It'd be a complete waste of time. So some things to kind of consider whenever you're presenting. First, think of the audience. Who is going to be listening to, or not just listening, who's going to be consuming whatever information you're providing? What are their backgrounds? Are you presenting to a lot of finance people? You should probably have a lot of financial figures. Are you presenting to a different group? Let's say you're presenting to a sales team. Have things relevant to sales. Presenting to whatever group you can imagine. You tailor whatever information to the people who are going to be consuming it. Think about the data itself. Think about how you can most effectively share different types of data. If you have something with only 1 or 2 different options, it probably makes sense to have some sort of a distribution of the percentage of those options. So think about you had a decision: are you going to come to class today? Yes, no. You can easily present that with a pie chart. There's different approaches. You could also do a bar chart, I guess. Really no right answer there. So just kind of consider how many options you're going to have, what sort of things you're trying to convey. Then, of course, think about biases. So this is an interesting scenario. Something similar happened to me. I'm not going to mention any names, but imagine you were presenting analytics and you had something that was unfavorable to your department, and you're told not to have it in there. Should you have that in there? So your boss tells you not to include something. Do you not include it? It's easy to say you should still include it, but realistically, would you still include it? I'm not here to ask that, but that's certainly something to consider. It's going to have a lot of interesting ethical problems associated with presenting analytics. You can choose whether or not to include something. You can choose whether to perform transformations to make something look more favorable than it actually is. I'm not going to go into too much details there. Let's just leave it at that. Talking about presentations themselves, there's a lot of different tools you can use. Of course, the most basic one, basic business report. You know, you've got your report there. It's got an executive summary. It's got a table of contents. It's got what you're trying to talk about, you know, the general message. It's got some facts. It's got some good figures in there. All that sort of good stuff. It's got your recommendation at the end. Basic business report. Used pretty regularly. Certainly going to be a document that you're probably going to come across at some point in your career. Poster. Everyone knows what a poster is. Slideshow. Everyone knows what a slideshow is as well. Certainly those are things that you'll be using. Presentation. You know, presenting information. How do you best do that to keep people's interest? Certainly lots of different approaches. I'm not here to say I'm an expert at it, but yeah, certainly you want to make sure that you're doing these things. But most of the time, you're not just going to be using one of these. You're going to be using some sort of combination. So say you were giving a presentation on the sales figures for, let's say you're a manager at a branch, and you're giving sales figures. You may have a presentation where you kind of discuss the sales figures, but you may also have a handout. Handout may have graphs on it. It may have financial figures on it. It may have something like that. And you would certainly want to make sure that you're kind of having 2 or 3 different approaches you're using to present the information. So that can certainly help keep people engaged. If they have something in front of them, they can take notes on it. They can ask questions about it. They can see it more clearly. Because, you know, you're presenting something, let's say you're in a conference room, people may not all be facing the screen directly. You may have some people who are facing it very far away. Other people may have it too close to be able to see. So you really don't necessarily know how exactly people will be able to see the information. So it's best to have it in multiple formats if possible. Kind of talking about representing data. Of course, you can use this a lot of different ways. Generally speaking, you want to put things in a nice table. Could use a chart as well. Let's say you had the results of some analysis that you ran. Say you did a basic regression on whatever you wanted to do, maybe predicting future sales. So you kind of see that's what you could do. You could present this inside of a table. This is what we found for the different coefficients for the variables that we included. This is what this means. You, of course, have to write that up. But that's certainly one way you could approach that. If you just want to look at the data itself, use a graph, some sort of a representation, line graph, bar graph, pie graph, whatever you want to use. Certainly going to be dependent upon the data itself. You can use a visualization. Visualizations are kind of cool. They're animated. They allow you to kind of show changes in a more engaging way. Could also allow you to show different things. I've got an example here I'm going to pull up in a second. You could also use a dashboard. So dashboard is going to be updated in real time. It's going to allow you to include pretty much anything you want. If you want to include real-time sales, you can. If you want to include, let's say, year-to-date sales, you can do that as well. If you have the data, you can do it inside of a dashboard. Really straightforward. Let's take a look at this visualization example. Okay, this is a visualization that I found online. And what this is saying is it's got 3 different sort of frames where it's kind of transitioning between them. So one of them is what people are worried about, what sort of types of death. Then we have the actual causes of death. And then we also have one about what does the media have in their headlines. So you kind of see what causes a lot of cancer, a lot of heart disease. But then people tend to be worried more about some other things. And then you see what the media reports on. Certainly, I think this is kind of interesting to see. This is use of a visualization. It's a little bit graphic topic, I suppose. So I certainly apologize for that. But this is just one example that I found online. Okay, so that's the visualization. Let's take a look at a dashboard. So like I said, this is where we put anything we want to in there. A lot of times, depending on the platform that we're using, we can easily take this, let's say we had annual sales, we could drill down a little bit further, get quarterly sales, get monthly sales, weekly, daily, hourly. Probably get more in depth if you have that data. Of course, you may not have, sales by the minute, although most of the time you probably would if you have transactions. So it's going to be pretty straightforward to allow you for things like that. Beyond that, just put whatever you think is important. Any sort of key indicator that you believe is important to the success or failure of your firm, include it. Certainly, in a lot of cases, you may have a dashboard for system availability. Think back to CIA triad: confidentiality, availability, and integrity. Availability is a very important concept, and making sure the system is accessible is going to be something that's going to be of interest, not just internal use, but also external use potentially as well. You could certainly include different trends that are happening. So you can certainly do some basic forecasting. We're going to talk about that in a couple slides. But basically, you just see what is likely to happen in the future based on what's happened in the past. Then, of course, you can also have exception reports. Let's say you are a warehouse. You want to see, are we running low on anything? Have an exception report. And here's one example. Again, infinite amount of examples. You can put literally anything you wanted to, assuming you have the data. But this just kind of has some different figures and charts here. So you'll see they have up here their revenue. It's listed as $2 billion. You may want to have it with a greater number of significant digits than just one, but they didn't, so that's fine. You see they've got some pie charts here, some bar charts, lots of great types of charts. And this is what this company believes is important to understand. So you can quickly see this information updated very rapidly. It could be very beneficial. So in general, though, whenever you're presenting this information, you want to make sure that it's readable. Because let's say you're presenting information and it's not readable. What's that going to do? It means no one understands what you're presenting. So that could certainly be a bad thing if you were to present something with the goal of disseminating information. Think back to the roles of manager. You have that informational role and you're not disseminating information effectively, you're not a good manager, at least not in that aspect. So that's certainly going to be something to consider. And we'll see some examples of this in a couple slides. We have clearness, though, making sure the information is presented in a way that's clear. There's no ambiguity. You can imagine, let's say you're presenting information and you didn't label it. That's not clear. So next thing to consider, having all the necessary information. You don't want to leave anything important out, but you also don't want to just overfill a graph with a bunch of stuff that doesn't matter, or having too much stuff on a single graph. It's okay to have multiple graphs. That's certainly going to be preferable to having one graph with everything included. And then lastly, appropriate colors. This is an important thing. A large percentage, don't know it off the top of my head, but a large percentage of people can't distinguish certain colors. I think red-green is a very common example of color blindness. So not only is it good to use colors, you can also use colors in addition to different shapes. And that's pretty easy and built into most packages nowadays, just to kind of allow that enhanced level of accessibility. So here's some examples of bad graphs. Anyone want to take a stab and say why this graph is bad? Any ideas for why this is not a good graph? The background, it's a bunch of bananas. Is it funny? I think it's pretty funny. But you can't really see what's happening. If you want to get the stuff, not only that, it's 3D. So there's really too many things happening. We have too many dimensions. We have the different countries. We have the different years. And then we have sales figures. One too many dimensions. You should really not have this, in my opinion at least, done in a bar chart. You could do it in a line chart, where you'd have different lines for each year. That'd be okay. But you really don't want to do this inside of a bar chart because it's impossible to tell. You can't tell what the sales for Honduras were in 1998. Can't be done. You can make a guess, but because it's in that 3D sort of shape, it's very difficult to determine where the line actually is. Let's look at this example right here. What's wrong with this pie chart? Can you read these? Can anyone read these? I'm not even sure I could read these, and I'm right beside it. So not only is it difficult to read, it's a pie chart. Pie charts are really for not more than like 4 or 5 different things. You start getting much more than that, it's very difficult to read and surmise information. So, you can't, for one thing, you can't distinguish the colors. What's the difference between this gold right here, this gold right here, this one right here, and so on? The colors are basically the same. And there's a lot of problems with this. Like I said, you can't tell what relative proportion any of those represent. They all look like they're roughly 1%. But you think about it, if this is 100 most active tweeters, and then some of these are obviously much larger than 1%, then it's impossible for the small ones to be representative of 1%. So what's the point of this graph? Can you get any information from it? You can get some information, but not as much as you could otherwise using a more appropriate visualization. So here's an example of a good graph. Now, why is this a good graph? Someone take a stab and tell me why this is a good graph. All right. So just kind of looking at it, it's broken down into category. We've got a type of vehicle, and then we've got the frequency, and we've also got the origin. So we've got Asia, Europe, and USA. So we can easily tell what the relative portion of those are. We can look and we can see, first of all, what's the most common type of vehicle, according to this chart? Look and see which one has the highest bar. So we can see it's going to be the sedan. That's true of all the different regions. Then we can also see, how many sedans one region had. So we can kind of tell that relative amount. I'd say that Asia had 95, whatever frequency represents. You got no idea. Just found this online. 95 sedan. We can see, the SUV, a little bit less popular. Hybrid, extremely unpopular there. So we can certainly see this sort of information very easily. Now again, I'm not saying this is an accurate representation of vehicles. Probably not. I don't think there's too many wagons sold in the United States, at least. Not too familiar with Asia, I guess, but I think this is probably a little bit outdated. I don't think sedans are all that popular either. I think hybrids are probably a little bit more popular than this, but you get the idea. You can easily tell what information is trying to be communicated by this visualization. Here's another good graph. I think you could probably tell the difference between the color, but if not, notice that the shapes are different. You have a square for the green, which is the gross revenue. Makes sense. Revenue's green, money's green. It's also good. And then, of course, you have the black represented by the number of employees dressing business casual. It's going to be a circle. So you can easily kind of tell what the relative distributions of these are. Now, interestingly enough, they have two different axes here, which is pretty typical if you have two different types of things you're representing. So one thing you're representing is how many people are wearing a tie. The other thing you're representing is the revenue. Now, are these two actually related? Probably not. You wouldn't anticipate this would cause a big difference. And looking at this, you can certainly tell it doesn't seem to have a very consistent relationship. So it kind of increases here, decreases slightly, increases again. Whereas this, people actually using it business casual all over the place as well. So I'm not saying these things are actually related. I'm just saying from a visual standpoint, this is a fine graph. Certainly nothing wrong with it from a visual standpoint. Talk about some of the specific tools you can use. Of course, you can use Excel to make a lot of graphs. You can certainly present the stuff via PowerPoint if you wanted. You got a lot of options there. Use Microsoft Word, business reports. I think you're pretty familiar with all that. You can also use some more sort of in-depth business intelligence visualization approaches. So two most common things you'll come across, Microsoft Power BI as well as Tableau. So those are two applications that are pretty commonly used to represent not just dashboards, but really any type of analytics. You can easily visualize data. These are not going to be something where you're going to be able to do a lot of analysis, although you'll be able to do some. Probably for a lot of jobs, it'll be all you'll ever need. But if you're trying to do things like some sort of advanced prediction, some sort of forecasting, that sort of stuff, you're probably better off using a different tool. It's probably going to be more in terms of the data analysis tools, using something like R, SAS, or Stata. So those are going to be where you're going to be doing a lot more of the analytic-focused tasks. Let's actually talk a little more about analytics. So I said we would in a couple slides. I think that couple slides was about half dozen, but that's okay. So in descriptive analytics, what we're really doing is we're taking the data and we're just giving basic features of it. So think of this as we're taking some sort of a description of it. And a lot of times what we're doing, you're getting basic summary statistics. If you've had a business stats class, you've probably had some data set, you've probably done some sort of summary statistics on it. Saying things like, what is the average? What is the middle value, the median. What is the mode, most commonly occurring value? What's the standard deviation? In other words, how much deviation is there inside of the values from one value to another? What's the skew? Look at the distributional shape. All those sorts of things. Things you've probably done before. So, of course, this could be used in decision support systems. We're looking, and we're just describing what's there. We're not making any predictions or anything. We're just saying, how sensitive would it be to changes? Stuff like that. Could we accomplish something given what we've already done? So that's what we're kind of doing there. Could also use data mining here. So again, we're just describing what's there. We're not making any sort of determination based upon that. So things like sentiment analysis, where we're determining, is this going to be something that is going to be positive, or is this going to be something where people are viewing it negatively? Certainly going to be something interesting. Also taking a look, what sort of historical patterns do we have inside the data? That's inside of Descriptive Analytics. Then we have Predictive Analytics. So we've kind of moved past just describing it. We're saying, what is likely to happen? So we're making some sort of prediction. Now, there's a lot of different types of forecasts we can do. We've got that in a couple slides. But basically what we're doing here is we're actually getting a little bit more predictive. So this could be things like looking at future behaviors, things like fraud. How do we predict whether a transaction is or is not fraud? Well, there's certainly lots of approaches we could use, most of which are very effective. It's things like regression. Regression, we're predicting something. We're progressing, and we're then gaining some additional insight on what is going on with our data. Forecasting, again, that's a couple slides from now. So I guess it's not a couple slides, I guess it's one. So different types of forecasting. The whole goal here is to predict a future outcome. And of course, we do that with the past data. So we have the naive forecast. That's the first type of forecast. All we're doing inside of a naive forecast, we're taking the previous value. That is our forecasted value. So if we had sales, we want to predict future sales, how do we do that? Look at the most recent sales figure we have. That's our forecast. That's all we have to do. And of course, we want to do simple moving average. We take an average of the most recent sales periods. Let's say we want to predict Q4 sales. We had Q1, Q2, and Q3. All we'd have to do is average those three together. Then if we want to predict, let's say, Q1, we'd have Q4 sales, Q3 sales, Q2 sales. Just average those together. It's really straightforward. Weighted moving average, a little bit different. So just like with a moving average, you're just weighting, or you're just averaging things. But in this case, we're actually going to apply weights to each of the periods. And the weights will be given. They could vary pretty much any way possible. But they're always going to add to 1. And the reason I have to add to 1 is, if they don't add up to 1, it means you're actually applying a transformation. So you're not just multiplying by 1, you're multiplying by something greater than or less than 1. So that's an important thing there. Let's say we wanted to have a weight of 0.5, 0.3, and 0.2. So we take that 0.5, multiply it by the most recent period that we have, take that 0.2, 0.3 rather, multiply that by the second most recent period, and then take the 0.2, multiply it by the third most recent period. That's going to give us the weighted moving average. And again, the weights will be given. They're not going to be something where you're going to come up with them on an exam question, anything like that. They're going to be provided. So this could be 0.7, 0.2, and 0.1. Those could be valid weights. They add up to 1. It could be 0.33, 0.33, 0.34. I'm not sure why you would do that, but you could. So there's really no right or wrong answer there. Let's kind of keep that in mind. Simple exponential smoothing, that's going to be an approach where basically you're going to take the forecast value and you're going to take the actual most recent occurring value and you're going to apply a constant to them. It's going to be between 0 and 1, and then it's going to be between 1 minus 0, the previous constant there. It's going to multiply them together and add them. So pretty straightforward. Again, because it adds to 1, or it doesn't add to 1, because it's between 0 and 1, and then you take 1 minus that, it's going to be the same as multiplying by 1. Not mathematically, but certainly you're not going to be applying any sort of transformation like that. Does that make sense? We'll see examples next class. All right. We have seasonality forecasting. That's where we're going to forecast based on season. So again, we can use any sort of period we want. We can use quarterly seasons. We could use monthly seasons, weekly. Doesn't matter. All we're going to do, we're going to take a seasonal constant. We're going to multiply it by what we anticipate the annual sales to be. And that's going to give us what we expect to have for a given period. Then lastly, trend forecasting. We're going to base things on a trend. Let's say even if the data is suggesting that we're going to see a decrease in the next three, in the previous three, let's say that we overall are still anticipating a larger increase. We can certainly apply that. So that's pretty much what we're talking about here. Any questions? Again, we're going to do examples next class, so don't worry too much about the specifics, but that's kind of the overall sort of thing. Nothing too complicated. So now we have the prescriptive analytics. And this is where we're actually going to prescribe an action. So you go to the doctor. What does the doctor give you? They give you a prescription. The prescription is to fix whatever you went to the doctor for. Certainly you can think of a lot of examples of that. And I like to think of a driverless car. So you think about the driving process. You have the identify, you look and see what's around you, you predict what will happen, and then you decide and execute. That's where we're at. We're actually in the deciding and executing phase. So that's what we're doing inside the prescriptive. Think about the supply chain. You think, what is going on inside the supply chain? How can we react to changes? You make a change. You do it. So that's all we're talking about with prescriptive analytics here. So just kind of wrap things up. We talked about the managerial process a little bit. We talked about some basic analytics. Next class, we will pick this up and we'll actually go through, do some examples in Excel. That's what you're likely to see on the exam. Apart from that, hope everyone has a great day. I'll be up here if you have any questions.